Well, how's it going, folks? Hope everybody's doing good. Well, it's kind of slow out in the old shop there tonight, but I was taking some inventory and getting ready to order some new parts. I gotta get some new potentiometers, and I'm getting low on stuff. Input jacks. I gotta get some foot switches for pedals. But anyways, I dug out my breadboard tonight out of the cabinet with all my pedal stuff. I'm not going to get in too deep on this tonight, but I think eventually what I'd like to do is show you guys how to breadboard a circuit, maybe build your own pedal. Maybe we'll build a fuzz pedal or something easy to start out with, but so a breadboard is what you're looking at right here, and what that is, you can get these on eBay, or hobby places have them. This is actually two small breadboards hooked together. They split right here in the middle. So basically what you have here, let me get down on this bottom one so you can see it. You're going to have a positive and a negative down here, okay? And it's going to be the same up there. You got another one there and another one there on each outer edge of each breadboard has one of these. And what it does, if you hook power, or say a battery, 9-volt battery or something to this, you'd have a positive and a negative on the battery. So you hook the positive and the negative corresponding. Now when you hook to this positive, that's going to power this whole strip all the way down. Okay? And the same with the negative. When you hook a negative side in it, it's all the way down. And then you have these A, B, C, D, and E. And those correspond this way. So if you plug something in, let's say this is plugged into this line right here. If I plug this in here, if this is sending power through here, if I plug this wire in here, it's going to power it. So these ones run this way, and these ones run this way, okay? So basically, what we got here is I just got a piece of aluminum ABS sheeting. It's 1/4 inch thick. It's nice and rigid. You could use a piece of wood, a plywood, or anything. And then I got a piece of angle iron here on the back. So what I got there, I just glued it. So it's an angle iron that goes underneath. It's glued. You can actually see some of the glue that squeezed out. So then I got an input jack, I got an output jack, and then I got a stereo jack right here. Now I took these pots out, but I had a 20K, a 250K, and a 500K pot. And I just leave those, have them wired, wires tagged onto them. So you could use them, you just run your wires right off there into your circuit that you're building. So it's kind of handy to have a setup like this. And you've already got pots all ready to go with wires soldered onto them, so you can just jump right onto the breadboard when you need to do it. Or add a pot, volume or a tone, etc. So I haven't done this for quite a while, and boy, I'll tell you, when you don't do this every day, it takes a while to get your bearings back on what you're doing here. So, but this was one of the last circuits I worked on, and I put it in the cupboard because my cat kept trying to get at it, and he was messing with it, and I didn't want him to ruin it because I didn't have this one written down yet. So I just wrote it out on a piece of paper what I had, and it's not quite finished, but what it is there's 3 LEDs here. Now, LEDs, they're just a diode that emit light, and diodes are used, they use them to clip the signal and distort the signal, and that's what gives you overdrive in some circuits. Well, LEDs, and they all have different values, so the different values make the sound different. Well, LEDs will do the same thing, and they actually sound different. There's frequency involved in each one. There's differences in frequency, I should say. I don't want to get too deep in this and confuse you, but so basically what this is, I've got some pedals that use diodes for clipping and making distorted signals, and some of them are actually switchable with the piano style switches. You take the back cover off and you can switch the diode configurations and get different sounds and styles of overdrive and distortion, which is really nice. But I've never seen anybody do it with a knob and actually be able to blend the diodes together. So that's what we're looking at here, or the stat of it. And I've actually played through this, and I can use 1 diode, I can use 2 diodes, I can blend between them, and then I got a switch that switches over to the red one, and I can blend between those two. It's very subtle, but with a pair of headphones on, you can really hear the difference. And basically what it's doing is just bleeding off frequencies, so each diode will sound different, as I said. One might sound a little darker and cloudier, one might sound a little brighter and more sparkle to it. And, these are mini LEDs. You can get full size, which I have too, but so anyways, I got a bunch of those are old capacitors. I got a bunch of them over here. And that's like gold, guys. Those are old Goodalls, Mallory's. Now, capacitors can come in many different shapes and sizes. These are old style here. And then you have newer, these are more newer style capacitors. These are electrolytics. You'll see there's a line on one side, and on these old ones you'll see there's a line too on one end of it. And what that means, they're directional, so current is only supposed to flow through one way, and it keeps current from flowing back through the circuit too. Those are electrolytics. Now, these are capacitors too, and you can see there's some orange drops. You guys probably know what those are. You've seen them in your guitars. Those are not electrolytics. You can hook those up in any direction. So, I just want to give you some brief stuff to start looking into if you guys want to do this. A good thing to do is keep a notebook when you start. Write down what the symbols are, what the components are, what they do, how they work. I'll go through some of this stuff with you guys as we go, but as you can see, smaller caps take out the low end. So if your capacitor has a smaller number value, it's going to take out the low end and it's going to be brighter sounding. A higher valued cap lets more low end through, so you're going to get a more beefy sound and not as bright. The treble will be bled off, and that's basically how that works with caps. But anyways, I'm gonna get the rest of my stuff dug out, and we'll go through the rest of the parts. I'll show you what some old resistors look like and what new ones look like. Just a brief history about this stuff. Here's a tube, okay? Now this was basically your first amplifier. This is what amplified the signal and made it louder. Great technology, you know. They blew over time and they would fail eventually. They were hot, heavy, cumbersome, so eventually they got rid of these and then they went to these. And that is a transistor. 3 legs on it. You have a base, an emitter, and a collector. That's a silicone version. I also have some in here. These are some old vintage germanium transistors. And when you're looking at transistors, there's going to be some letters in front of them. It'll be NPN or PNP. NPN means negative, positive, negative. And PNP is positive, negative, positive. Just so you know what those letters mean right now, it's probably not that important, but in the end, it's just the way they're wired and the way they emit and collect. So if you're using, like the first fuzz pedals were, if I get this right, I think they were PNP. I think. I mean, I might have this backwards. Don't get mad at me. But so everything was like a negative, a positive ground, basically, is how that, I think that's how those were. Everything was just backwards. And then they moved into silicone transistors, and those were usually just the opposite. So ground was ground and positive was positive. Now, you can get all kinds of different variations of transistors with different values. I'm holding like 600 or 800 transistors. They're not expensive. They're really cheap. And they work great. I love building with transistors. I do. It's got a unique tone to it. Now, after the transistors, they went to these guys. These are called op amps. Looks like a little insect. It's a little 8-legged chip that can deliver some serious power. And the nice thing about these, you can get I have sockets too that those plug into. So you can, in a circuit, you can remove this and plug a different value op amp in, etc. Pretty handy. They do make transistor sockets too, so you can interchange those. I don't happen to have any right here, but so the nice thing about breadboarding is this. For instance, I'll have a bunch of caps all made up with, you know, a bunch of different valued caps. I have a ton of them all wired up with legs on them, right? So what I'll do is I'll plug my guitar into this thing, run it out to my amp, and with the guitar hanging right on me, I can pull a capacitor out, put a different value one in, and start playing, and I don't have to wait around to hear the difference. I can do it right there in real time. It takes literally seconds to pull that out and put a different one in. It's really, really fun to do, guys. Once you get going, there's a little learning curve and a hump, learning your components, what they look like, because there are a lot of different styles of these. There's a lot of different styles of diodes. There's diodes that don't emit light too, so, you know, they just look like a little, almost like a resistor kind of. But we'll get into that more as we go along. Like I said, I have a bunch of vintage stuff and I have a bunch of new parts too. And another good thing to pick up is one of these. You can get these right on eBay. They're cheap, like 15 bucks, I don't know, something like that. But let's say I take this LED and so you stick it, whatever component you have, into these little slots, one leg in each, clamp it down, hit the button. Oh, I must not have had it in there good. Yeah, you see the light blink? And it tells you it's a diode, tells you what the capacitance, it's 16 picofarads, 2.73 volts. These are invaluable. You gotta have one of these, because, you know, like, if you don't know what the value of this transistor is, you're done. You gotta know which leg is which, and this will tell you which is of these three legs is the base, the emitter, the collector. You know, it works the same with resistors. You can test capacitors, and it will tell you what each component is too. These are very handy. Well worth whatever they cost now. This is my second one. The other one, just, we had to put that one to the rest. But anyhow, guys, I just want to give you a brief introduction to this stuff. And if you are interested in learning some of this, like I said, I may do a little series on just breadboarding in general, components, values, build a pedal, and kind of get you guys started out on your path of building. Once you get doing it, it's really fun. I mean, you will immediately start designing your own circuit, like I'm doing right here, just out of your own necessity. And once you understand how this works, this is really simple, basic stuff, honestly. It's not that it looks more complicated than it is. I taught myself. It took me a few years to get a good handle on it, but, you know, once you get doing it, I mean, this is one of the last circuits I built. I mean, that looks like insanity, I know, but that's a 2-transistor boost fuzz. I didn't finish it yet. I still need to add the foot switch, but I built this out of old ground terminal strips and soldered the parts in between. All vintage caps. Nice stuff. They sound good. I test them all first. That's why I say get a tester, especially if you're using older parts, even new parts. You want to test them, make sure, you know, they're good before you solder anything in, because once you get something like that soldered together and there's one part in there that doesn't work, well, you won't be sleeping that night, trust me. Well, alright guys, it's getting along. This could be a long one here, so I didn't really want to get wrenching on guitars tonight, so I figured I'd dig this stuff out and kind of give you an introduction to what we may get into here, if you guys are game for it. And I gotta order some parts, and I got some new pedal cases. I got some standard ones. This is one I made for this circuit with the 3 LEDs, but I stick circuits in anything. I mean, I don't care what it is. If I had an old Nintendo controller, I could probably jam a fuzz circuit in there or something. Whatever I can find. Walkmans, that's fun to do. Clock radios. I mean, the sky's the limit once you start doing it. And you don't want the everyday stomp box. Build your own enclosure and stuff a circuit in it. I mean, it's not that hard, guys. Once you get going, it really becomes kind of simple, and It does take some thought process, which is really the fun part. It really takes some planning sometimes to get these right. But like I said, the neat thing is being able to change these parts right while your guitar's hanging on you and you're listening to it in real time. That was a major breakthrough for me, because then I can actually sculpt a circuit for a Les Paul. I could sculpt a circuit just for a Stratocaster. You'll see what I mean once we get going. Then you'll see that most pedal manufacturers are just kind of building a broad circuit that will sort of work on both, humbuckers and singles. But when you narrow it down and try to pinpoint a pedal just for a single coil or a humbucker, you'll see what I'm talking about. It really is a major difference, and you can get some amazing sounding pedals with little knowledge and very little circuitry. Honestly, you don't need a lot to make a good pedal. All right, guys. Geez, we're over 20 minutes on this one. Okay, we'll get something out tomorrow. I'll shoot a couple vids maybe tomorrow, and I'll dig something else out to work on. I gotta finish making my list, guys. All right, we'll see you later.